Hey everyone, this is FixReef, and today we have yet another Apex EB832 in for repair. I have not done a video on repairing one of these in a while, however this one is slightly different and it I think deserves a separate video. So this came in with no specific issue. The owner told me that they acquired this unit from another reefer who did a repair previously. So this is a previous repair attempt. So they wanted me to take a look inside and make sure that the unit is sound and working order and is not going to cause any trouble when they plug it into their system. And I think it's a reasonable request given that this is going to control vital parts of a very complicated and expensive reefing system. So now let's take a look inside and see what we have. I haven't had a chance to plug it in yet to see if anything comes on, if any of the lights come on. So let's see what's inside. Looks like this is broken. Okay, let's take it apart. Okay, it looks like this came off. This is a very common problem. If you're not careful, especially if you're using power tools to remove the screws, chances are very good that you're going to be you end up taking this off. So it looks like they tried to glue it back in, but obviously it did not hold. So we'll have to deal with that problem later. Let's see what else is wrong. It's obviously an older system with an old cheap power supply. I can see that there was an attempt to repair this power supply and it was done in place. You can see that this is melted a little bit here and here. The fan is actually inserted the wrong way. So the fan is inserted the wrong way and one of the AC wires is pinched. That's not good. But the fan is supposed to be facing the label out. It's supposed to blow the air out of the unit and not into the unit. Okay, aside from this, not a whole lot else visible. Let's keep taking it apart. So if they did the replacement of the 12-volt power supply in place here, it means that they never took any of this off. So we don't know what we're going to see on the other side. Hopefully it's going to be good. All right, let's take a closer look. Oh yeah, that's not great. Hopefully you can see. I can see some corrosion. Hopefully you'll be able to see some of it as well. But there is. It looks like this was water damaged. Right around this controller, I can see. Let me zoom in. Okay, so right around this controller, there's corrosion around the capacitor and around the resistors. All of these diodes over here badly corroded. There is some corrosion across these diodes as well. A little bit over here, but not as bad. Optocouplers have some corrosion around them. This I'll have to see. This looks like there is a diode over here, but it looks like it's shifted. It could have just been, a problem with the initial, problem with the initial install. And there is corrosion, a good amount of corrosion around the buck converter here. That's another big problem. So the buck converter, this area, and actually this area as well has quite a bit of corrosion on it. The 24-volt power supply seems intact, which is kind of odd. For the most part, when I see water damage, I see water damage around the area of the 24-volt power supply because it's sort of towards the bottom of the unit, and sometimes also this area, and especially the connectors. So let's actually take a look at what the connectors look like. they're not bad. Actually, they're in very good shape. Okay, keep on inspecting. Let's, yeah, that's where they tried to replace the power supply, the 12-volt power supply, so there is a little bit of mess here, but nothing critical. The power supply itself has been replaced with the same low quality capacitors, so those capacitors will blow up just as fast as they did on the original power supply. That is not something that I recommend. Yeah, you can see that they've melted the relay casing around and outside a little bit, but that's not critical. Nothing horrible. I will have to remove, so what we're going to need to do is we're going to need to remove this power supply. I'm going to upgrade all of the capacitors on the power supply, clean all of this up, make sure that the connection is proper, because I do not see a good connection around here. I see there are gaps between here and here. There are gaps on the pins, and I can't really see my, ooh, that's not good. Looks like the trace came off entirely. The trace came off entirely. Yeah, we'll need to take this power supply off and see what's inside. Yeah, so this is what happens when the repair is not done professionally. I mean, I still encourage anyone to try to do this, but I ask to please do it as professionally as possible. I think that it just better long term to do it this way. That way, you're not going to have anything failing on you when this is plugged in, and for that matter, even causing some type of fire damage. You don't want that either. So, all right, let's start taking this whole thing apart and start removing all of the corrosion or all of the damaged traces and fixing them. First off, I'm going to start by removing the power supply. I think it makes sense to repeat these procedures here and there every once in a while, so that, you know, those of you who haven't had a chance to watch some of my very early videos and get to see it now. And also, now that I've done a lot of this, you know, I also gained a little bit of experience and speed as well at working on these controllers. In fact, if you remember, I started a jar of all of the capacitors from this 12-volt power supplies a while back, and just to show you the amount of capacitors, these are just off of the 12-volt power supply on EB832s. That's what I've been able to so far replace. I don't even know how many dozens and dozens and dozens of these units I was able to repair with this. But anyway, so we're going to add a little bit of leaded solder to lower the temperature. It was probably already leaded solder in there before from previous repair attempt, but it doesn't matter. Now, just one of them out. And especially since there was damage to the traces, we have to be really careful. Okay, and now the power supply is out. Now, while I still have it here, I usually like to clean up the holes here and make sure that I have those holes prepared for the next install. This area is particularly messy from the previous repair attempt. Yeah, you can see that they pulled them out and potentially damaged some of the screw holes. That's alright. Let's just clean up all the mess the best we can. Get it to as new a condition as we possibly can. And I may have to go under the microscope on the damage traces to actually see how much damage there was and what can be done about it. Okay. Yeah, this one I will have to examine under the microscope because quite a bit of the trace around the hole was pulled. Yeah, let me see if I can zoom in to show. So this half is completely gone. This half is still there, so we can run it. Let's see what this is going to look like on the other side. Yeah, this area is nice and clean. No problem here. This area, however, is completely messed up, and the trace is entirely disconnected. completely disconnected from the unit. Oh, that's a shame. All right, not a big deal. We'll just have to. The problem is that it's in such this area over here that's tough to get in, but we'll be able to get in there and try to fix it. This is the same through hole as here that's damaged, so we'll need to work on that. Okay, we'll work on that in a bit. Let's see what we can do with all of this corrosion here. I don't think that I need to necessarily get this into in ultrasonic cleaner. Instead, I'm just going to carefully remove some of these components, clean everything up, and either replace them if they're completely gone, or clean them up and put them back in. Let's do most of this under the microscope. Okay, so let's start with the buck converter. I think that that's a fairly important component to get right. So what I'm going to do is I'm going to remove the whole thing entirely. Hopefully it works. And now all I have to do is just clean up, remove the old solder, put the fresh one in, and put the component back in place. This removes all of the corrosion that existed and also exposes any of the corrosion that was that potentially damaged the traces. Looks like we either just accidentally removed the resistor or it got corroded off. That's our opportunity to actually make it work. Nice and clean solder around. Now let's clean up the area around the buck converter. This removes the remaining corrosion and also any extra flux and just debris and dirt. And as a result, we get this. So you can see that a little bit, just a tiny bit of the traces in a couple of places got corroded off, but it's mostly okay. So I'm gonna put the solder back on. And now, let's see if we can get this back. Okay, looks like it went in nice and easy. Just maybe a little bit of extra solder to ensure that all of the pins are connected. There is some corrosion residue on the pins on the top, so should be able to scrape it off. Alright, while we're here, we might as well take care of this issue. There are two diodes here. Yeah, this one got corroded off quite a bit. It's not horrible yet. The pads are still in place, but the corrosion was fairly significant. Let's see if we can scrape it off. No, not bad. That's it. Nice and clean. Shiny metal is a very good sign. Yeah, nice and clean now, and all the corrosion is gone. If this corrosion were to be left untreated, my bet is that within 3 months, maybe 4, this EB832 would have failed. So we're going to go ahead and prevent that from happening. Alright, let's take a look at the condition of the pads on the other side of this diodes. They may not be as great. Okay, clean them up nicely. This one's concerned, where there was the most corrosion, of course. Looks good. Okay, now we can install both of this. Almost. I still want to have this whole pad cleaned up. And the reason I want that is because this is the high voltage and high current diodes. So I want to make sure that the surface is proper. And you can see as I'm scrubbing it, some debris is coming off. So very good. Very good. Now the whole thing is shiny. Solid. And the second one. And we got both of them. I will clean up later. We still have quite a bit of cleaning to do. Let's see these guys, for example. These are actually fairly solid. So what I'm going to do is I'm just going to remove the remove all of the salt around and see and just reflow in place. Yeah, this is in a still very good shape. Just important to remove all of the salt. And what we're going to do next, because a little bit of solder got washed off with the salt and corrosion from before. Let me get. Or maybe I'll just remove them because it looks like there is some salt underneath and it's hard to get it out. Let's remove them both. This way I can easily clean everything up. And there is a little bit of corrosion underneath, so it's just easier to and better to remove everything. And once removed, we will be able to see how much of this was actually corroded off, how much of it is still in place, and was it all worth repairing. Okay, yeah, for the most part, you can kind of see a little bit of corroded away trace, or a pad rather, but now the corrosion is stopped, everything bad is removed. All we have to do is just put everything back in place. And let's put both of the optocouplers back. Much better now. Okay, that area is all nice and clean. Now let's take a look at, oh yes, there's another one. This one's pretty bad. This one is pretty bad because I can see that at least one capacitor is mostly messed up. And I mean, for that matter, both of the diodes, like in the previous case, are all messed up too. Yeah, this all came off effortlessly. Which is once again a bad sign. It means that there is a lot of unwanted corrosion around. Let's see how much of it we're going to be able to get off. A fair amount, I would say. I'm also going to remove some solder because there is corrosion on that solder off of these pins. I'm actually concerned that this, oh no, it's not bad. I think that this can be just resoldered. Let's do that first. Because I think that these pins, I could be wrong, but these pins are likely relay pins. Once again, anything that is relay is going to be higher current. So we want to make sure that there is a solid connection. and nothing is corroded. All right, quite a bit of mess. Let's clean up. I'm still not too happy. So the pin on the left turned out really good. The pin on the right is still dark. Let's see if we can get the right pin cleaned up. Oh, there you go. Now the crud is coming off. Very clean. Much better. Now we have nice, clean pins. Now let's get some shiny solder on all of the pads. And let's install the components. Yep, took right away. And the surface of it is going to be cleaned up from all of the previous corrosion. And now both of the diodes. Okay. Nice and solid. Okay. All right, we got this area all cleaned up. We'll just need to wash it, everything afterwards. And the last bad area is this, right around the controller. I think that the idea is about the same. Let's take off both components, clean the area around, put them back in. All right. It's mostly looking good because the pads have not been completely corroded off. So we should be able to get all of this off. Let's see how well we did. Alright, so one thing that I need to make sure here is that this trace didn't get disconnected due to corrosion anyway. Doesn't look like it. Good. Everything else looks fairly clean. So fresh solder goes back in. And let's reinstall the components. The capacitor actually looks fairly good. Both sides are nice and shiny on the underneath, so it should be able to go in fairly easily. Right there, nice and clean. Perfect. And now the quad resistor. These resistors are used for current sensing for each of the outlet on the EB832. That's it. Okay, doesn't look like much, quite a bit of mess with flux and stuff, but other than that, it looks good. I do not see any other corrosion related issues on this side of the board anyway, so I'm gonna clean everything up and we'll get over to the 12-volt power supply problem. So let's take a look. All of the corrosion on all of the areas that we've cleaned up is gone and everything looks practically like new. Hopefully it's going to work that way too. But of course we are not completely done with this board yet, because now we have to deal with the fact that the trace on this 12-volt power supply connection is missing. Let's figure out how we're going to repair this. The basic idea is that since this trace came off, it needs to be extended, potentially even run through the hole along with the pin for the power supply, and perhaps connect it over on the other side. Good news is that there is nothing else going on here, so we should be able to do this fairly easily. The size of the trace is very significant, so it means that it's taking quite a bit of current. So we'll need to make sure that whatever we run through to repair it is going to be thick enough to match the thickness of the trace. So I would imagine that the wire of this thickness is going to be sufficient. I just have to make sure that there is enough room for the power supply pin to also come through. In the meantime, let's put it in and see if we can secure it. So first and foremost, we need to make sure that this end of the trace is not covered in paint or mask, and we can solder to it. So a bit of flux, and let's put some solder on there. Beautiful. Nice big blob of solder. Let's fish a wire through this hole and use this wire to connect to the trace. That's about it. some more flux. And let's secure it in place. That looks good. Okay, so now a good cleaning, and then cover everything in mask so that it stays in place even when heated. Just a tiny bit, nothing crazy. A few minutes of UV curing. Okay, now over on the other side, we can remove the excess wire, but not solder it yet because I will have to connect the power supply first. Okay, so for the upgrade, I first need to remove all 4 of these capacitors. I'm going to use my vise to help deal with this, and I'm going to mix in some leaded solder into all of the pins of the every single capacitor before I can remove them. Again, this is not the original capacitor that came with EB832. This was a replacement attempt done using another cheap power supply that you can get off of, eBay or AliExpress or Amazon. The problem is that, these replacements being cheap, they also come with very, very cheap parts, and they essentially inherit the same exact trouble, same exact problem as the originals. So I don't really see a whole lot of value in doing it this way. Nothing stopping you, of course, but you have to realize that given the failure rates of EB832s, replacing this will just extend the agony. Okay, so next I'm going to suck out all of the solder to expose the holes. Now let's start over here. All right, the toughest one. Primarily because there's so many components around them. But I think we got it. So while I'm here, I also like to quickly clean up the pins, because especially here on the repair attempt, there is half a pound of solder everywhere. Something like that. So let's get brand new capacitors for the replacement. Let's use this. a couple of this, and this. Before I attempt to install everything, let me also make sure that the pins that we have here are actually properly soldered and they don't have any gaps. Because I don't know how they were able to replace this power supply without removing the entire board, but I suspect that it was done through the top holes over here, and I just need to make sure that everything is in proper state. Okay, now it looks better. Just need to adjust this because they're crooked. Okay. Now let's install all of the caps. Let's start with this one. And now we can secure all the caps and the upgrade is complete. Okay, the upgrade is practically complete. Just snip off the excess wiring. Now we have a power supply that's actually going to last a while longer because the capacitors are much better quality. Alright, last but not least is we need to install it back. It would have been easy if not for the broken trace. So let's deal with that for a bit. Alright, so everything's inserted. Now the big question is, are we going to be able to connect I just realized something. When I inserted it and looked closer, let me show you. Looks like they moved the pins, and this is the broken off trace still hanging off of this one pin. Wow. Good thing that I've noticed it. I'll need to remove this before it touches something and shorts. Yeah, you can see the whole well, whole via is on here. Yeah, but it's definitely on the wrong side, so they swapped the pins from this side to this side and back. Okay, let's do it again. Okay, now it's a little bit better. Alright, I'm gonna start by securing the working pins first, the ones that have not been damaged. Should be nice and easy. Now what is left is the broken trace, except that we also have the wire here. To get this working, I'm going to use quite a bit more flux because we need to remove the coating and solder to the actual copper of the wire and not the surface. Something like that. My soldering is much cleaner than original apex soldering with all the flags over here, you can see. Okay, so let's take a closer look. The power supply is upgraded and fixed up. The trace is restored. We've removed all of the oxidations, all of the spots of oxidation, and cleaned up all of the components. Looks very, very clean to me. But of course, the biggest question is, will all of this work? So before I attach anything else to this, just the way it is, I'll plug it in and see if all of the LEDs that are supposed to be on are on. This will tell me if both of the power supplies are working. So let's take a look. Okay, I hear clicks. The green LED over here is working. The red LED over here is working. That's great. Now let's assemble it together and see if it works with the head unit. Okay, now we're partially assembled. I still need to fix the broken plastic inside, but for now, electrically, let's see if this all works. Let's connect it to the head unit. It connected. This is solid. The lights are on. Let me try to switch a few outlets. I'm going to turn them all off here first. Everything is off, and now, one at a time, every one of them will go on. Every single relay clicked, and every single outlet is on. Very good. Well, okay. I will have to test a few more things just simply because I don't know what the condition is of the 24 and 12 volt outputs. I'll have to fix the plastic on the side here, but it looks like we have it all otherwise electrically fixed. Let's just summarize. So this came in as a simple diagnostics request. A very smart idea, especially in cases like this. So not only is it that the 12 volt power supply was not replaced properly, it was also replaced with a lower quality power supply, which is not a recommended solution. And for whatever reason, it had multiple spots of corrosion on very important components. The buck converter that converts the power to the from the 24 volt power supply to the main controller to the Aquabus power outlets, the circuitry around the power sensing, just vital components that had corrosion on it. If not fixed, if left untreated, would have most definitely disabled this power bar in about 3 to 4 months. So this was a very good idea to have it diagnosed professionally, and hopefully this unit will last much longer now that it has been serviced. Well, this completes the repair. If you enjoyed it, please like and subscribe, and I will see you next time.